Good afternoon, students. How are you doing today?
Good afternoon, sir. I'm okay.
Thanks, Auntie. What about the rest of you?
Okay, sir.
Nice. Nice trivia. All right. We have what's on the plan for the agenda for today is I'm going to go through some probability distribution with you. If there is time, I may do some measures of central tendency. I did an example or a few examples with you on measures of central tendency. So I don't want to start off with that since I've already done something with you of our group data. What I now need to do is look at our probability distribution. Do a few examples of those, and if I get in a position where I can charge my device, I will go and put you in groups in a breakout room, so it is that I can go through individually the SPAs with you to do some final corrections. So what I'm going to do now is to share with you our probability distribution. Can you see my screen? No, I don't think so.
No, sir.
Because I'm not sharing it, that's why I'm not seeing it. Are you seeing this thing now?
Yes, sir.
Mm.
All right. So we're looking at some probability distribution, and we're going to be doing this topic by just doing some examples. Matter of fact, before you even go, how are you guys doing? I just jump in without even trying to find out. How are you guys doing? How is it going?
Sir, okay, I guess.
Yeah, okay, I guess.
Okay.
What are the preparations? Going better? You think the 3
Forward,
weeks?
sir.
It look okay, nice. Love the sound of that. You think the 3 weeks extension is going to do any good, or has it been doing any good?
Sir, not really sure, sir.
Really?
Okay, I know somebody had placed in the group that we don't have the extension for because it not make no difference, but um, I'm just checking on the veracity of that comment. But anyhow, all right. With that said, let us jump into the probability distribution. Just like correlation coefficient, the range of the correlation coefficient lies between -1 and +1. So I can't, if there's no way I can do a calculation for R and get something 1 point anything. It just does not max out. Neither can I get -1 point something, because the correlation coefficient lies between -1 and +1. Now, the sum of all probabilities cannot be greater than 1 either. The sum of all probabilities cannot be greater than 1. Cannot, never, ever, ever be greater than 1. So we're looking at the probability distribution here. And for example, it says the table shows the probability distribution of the random variable x. For random variable x, 1, 2, 3, 4. The probability of x there for 1 is 0.3. The probability of 2 is 0.1. 3 is 3a, and 4 is 2a. Now they're asking you to find the unknown, find the value of a for 2 marks to find the value of a. Now, if you understood what I just said a while ago, the sum of all probabilities cannot be greater than 1. Let me see. How would you go ahead and find the value of a? The sum of the probabilities cannot be greater than 1. The sum of the probabilities cannot be greater than 1. How would you find A? Talk to me. Háblame. Hello, guys. Are you hearing me?
Yes, sir.
Yes,
Thinking.
sir.
You talk to me, no man. I'm saying to you the sum of the probabilities cannot be greater than 1. And I gave you the probabilities of all 4, including an unknown. How do you think we're going to be finding the value of A?
So you're gonna add up everything and minus it from 1.
Very good. That's not D?
Yes, sir.
Yeah, thank you, sweetheart. So that's exactly what it is that we're going to be doing. Remember, the sum of the probabilities cannot be greater than 1. The sum of the probabilities cannot be greater than 1. Cannot be greater than 1. So what is going to happen is that I'm going to add up 0.3, 0.1, plus 3A plus 2A is 5A equals 1. So you have 1 minus 0.4 is 0.6. So I'm going to have 5A is equals to 0.6. Right? And then I divide both sides by 0.6 divided by 5, I'm going to get 0.12. So the value of A is 0.12. The value of A is 0.12. Can you look at that solution for me and tell me if you agree with it?
Yes, sir. I agree.
What about the rest of you? Thanks, Daniel. What about the rest of you?
Yes, sir. I agree.
Yes, sir.
Nice, Judy. Nice, Natty D. So remember now, the sum of all probabilities cannot be greater than 1. The sum of all probabilities equal 1. All right? So if you're given the probability distribution like this, and I feel like you're going to get something like this, you know. I really feel like you're going to, which is why I prepared this thing here for you. Kind of was very difficult going through the, you know, the SBAs and still doing the preparations, you know, kind of a little overwhelming, but this too shall pass. So whenever you're given a question such as this, it shows a probability distribution and it gives you an unknown. Just remember that the sum of probabilities cannot be greater than 1. The sum of the probabilities cannot be greater than 1. And when I add up all the probabilities, I'm going to be equaling to 1, and therefore my A is going to be 0.5. Now look at what it's asking you. It is now asking me to calculate the probability of X greater than 1 but less than 4. I'm to add up this. I'm supposed to find the probability of X greater than 1 but less than 4. What is the value of the probabilities greater than 1 but less than 4?
2 and 3.
Very good. Excellent. Excellent. 2 and 3. Let's go again. Before me even explaining anything more, I'm going to ask you to look at it. It says, let me read that double inequality, the probability of X greater than 1 but less than 4. We did this in limits and piecewise function. So you should all know how to read your double integral, your double inequalities by now. So yes, it's going to be between 2 and 3 because it's greater than 1, but it's less than 4. So it's going to be 2 and 3. Give me the sum then. What is the probability of it being greater than 1 but less than 4? Do we have the value of A?
Yes, sir.
Yes.
So 3 times the value of A plus 0.1 equals?
.46.
Is she correct? Am I correct?
Yes.
Very good. So that's how it is done. Now talk to me. Is this difficult?
No, sir.
It's not. It really isn't. So see the notation that I made here, that it is read X is greater than 1 but less than 4. Therefore, the accepted values of X are 2 and 3. 2 and 3. Are there any questions regarding those two questions that we just did?
Sir,
This one.
sir, why do you have p times 2 plus p times 3, but you don't have that in the second line?
No, it's not p times 2. No, I'm talking the p and the 2 there is the probability of 2, and the probability of 2 is 0.1.
Oh, okay.
And then the probability of 3 is going to be 3 times 0.12.
Okay, sir.
All right. All agreed? Everybody see it now?
Yes, sir.
All right. What if I said to you the probability of x greater than 1 but less than or equals to 4? What would be the answer? The probability of x greater than 1 but less than or equal to 4. What would be the answer?
2, 3, and 4.
Very good. It will be 2, 3, and 4, because it's not only less than 4, but it's also equals to 4. So you have to read your inequalities correctly, because what they could have asked you is the probability of x greater than or equals to 1, but less than or equals to 4. It means that it's all the values you're using, 1, 2, 3, and 4. They could have said to you the probability of x greater than or equals to 1, but less than 4. It means that you're using 1, 2, and 3. All right. They could also say the probability greater than 3. The probability greater than 3 is going to be only 4. So the answer will be 2 times 0.12. So you have to read your inequalities and interpret it. Are there any questions?
No, sir.
No, sir.
All right, thank you for answering. Johnny. Matthew, Tyree. Manisha.
Hold on for the answer, please. The 2. No, but we can go down for 1.
No, that's showing you another question. You're not seeing it?
Yes, I see it now.
Okay.
Sir, so why 0.1 come from?
Because that's a probability of 2. You see where I put p and 2? That's a probability of 2. Look at the question, my box. Right. So that's a probability of 2. Remember, the probability of x greater than 1 but less than 4 is only including 2 and 3. Is only including 2 and 3.
Oh, sorry, make it last.
Nice. All right. Now, ooh, the expectation of x for 2 marks. The expectation of x. Now, look at how we're going to do ex. The expectation of x is going to be mu subscript x, which is the mean. So look at what is going to happen. This is how we're calculating the expectation of x. It's a 1 times, look at the probability of x times the probability. So it's 1 times 0.3. See it there? 1 times 0.3 plus 2 times 0.1. 2 times 0.1 plus 3 times the value of a. But the value of a is 0.12. No, what's the value of a? 0.12. So it's going to be 3 times 3 times 0.12 times 3. And 3 times 0.12 is going to be 0.36. So it's going to be 3 times 0.36. Everybody see that?
Yes, sir.
Yes.
So remember, we have to substitute the value of a first. So in this one here, it's going to be 2 times 0.12. It's going to be 0.24. And it's going to be 4 times 0.24. 4 times 0.24. And then when we evaluate all of that, my expectation there is going to be 2.54. My expectation there is going to be 2.5 orders. Double check that calculation for me and tell me if you agree, please. Double check that calculation and tell me if you agree.
Yes, sir, it's correct.
All right, very nice. Any questions? Guys, talk to me now, please. Are there any questions?
No, sir.
All right. Now, what I should say to you is that, so there are several ways. We can calculate the measures of central tendency, mean, mode, and median from raw data. The raw data means that we're going to be adding up all the numbers and divide by the number of numbers. But the truth is, as I was explaining to you in class before, that sometimes you're not going to get the data raw. The data is already going to come to you, grouped. So just like your variance and your standard deviation, you can be given the raw data, like the TikTok videos that I sent to you. Well, I'm telling social media is not all that bad, because I was scrolling and found some TikTok videos, and I was like, hey, but isn't this what I'm teaching? So I sent them off to you. I hope you guys are watching them repeatedly so that you can see how we do the calculations. Those calculations are from the raw data. Raw data. Now, I'm going to show you how to calculate the variance and standard deviation, or var X, from this type of data, from the probability distribution. All right. Now, var X, the variance of X, var X, the variance of X, is going to be equals to EX squared minus EX all squared. Var X is going to be EX squared minus EX all squared. But remember, we would have calculated our expectation from before. We would have calculated our expectation from before, which is E of X, which is 2.54. So that is going to be 2.54 squares. Now, the expectation of X of X squared. Do you see where I get the all right, so that 0.3 that I have right there, that 0.3 that I have right there is going to be my X value squared times the probability. So it's 1 squared times 0.3, and 1 squared is 1, and 1 times 0.3 is 0.3. Look to see if you see the 0.3 right there.
Yes, sir.
Now, where I got the 4 times 0.1, look, it's going to be 2 times 2 is 4. So I'm squaring my x's and multiplying by the probabilities. So it's 2 squares, which is 4. 4 times 0.1, which is what I have there. Can you see that?
Yes, sir.
And that gives me 0.4. 0.04, sorry, 0.04. And then my 3 squares is going to be 9 times, oopsie daisy, 0.36, I think. Yes, 9 times 0.36. And the last one is going to be 16 times 0.24. $16 times 0.24. And all I'm doing right there is just evaluating this stuff. 0.3 plus 0.4, 0.04 rather, plus 0.32 plus 0.38. And I'm subtracting it from 2.54 squares and do all of that to get my 1.328. Now I want you to do that calculation for me on your own and confirm if I made a mistake or if my answer is correct, please. Let me know when you finish, please.
Correct, sir.
It's correcto. What about the rest of you?
Yes, sir, it's correct.
All right, thank you. The rest of you, talk to me, no, man. Is the rest of you understanding what is happening?
Sir, I just came into class.
You say it again?
Sorry, I just got here.
Oh, yes, okay, all right. All right, so a quick run through again. 3 and 3, 6 and 2, 8 and 2. Easy 10 marker, you know. Easy 10 marker. So it's a question on probability distribution. It's a question on probability distribution. And it is how the data is distributed. It means that I would have done an experiment for argument's sake. And this experiment, I got 0.3 one time. I got 0.1 two times. I got 0.36 three times, and so forth and so on. All right. Now I have my data, and I'm asking to find the value of A. Now remember, the sum of all probabilities equals 1, not greater than or less than. The sum of all probabilities equals 1. So what I'm expected to do is to add up all my probabilities and set it equals to 1. Add up all my probabilities and set it equals to 1. So I'm going to say 0.3 plus 0.1 plus 3a plus 2a equals 1. And then I'm going to end up with 0.4 plus 5a equals 1. I'm subtracting 0.4 from both sides. So I'm going to end up with 5a equals 0.6. Divide both sides by 5. A is 0.12. A is 0.12. Oh, guess what? No. All right. I don't know why I have that here. I mistyped something here. I don't know why I have that here. I have the probability of when x equals 1 is 0.3. I don't know why I put that there. That not help me with the question, but the other part says now to find the value, to find the probability of x greater than 1 but less than 4. The probability of x greater than 1 but less than 4. X is greater than 1, but x is less than 4. X is greater than 1, but x is less than 4. When you look at my values of x, I have 1, 2, 3, 4. So x is greater than 1. It's not equal to, it's greater than 1. So the value of x being greater than 1 is going to be 2, 3, and 4. But the other conditionality says it's less than 4. So it's only 2 and 3 we have. And then if you look at my solution, you see me have, I don't know why I have that there. That's not helping me. I'm going to delete it. For my solution, I'm saying the acceptable values of x will be 2 and 3. So the probability of 2 occurring is going to be 0.1, and the probability of 3 occurring is going to be 3 times 0.12. See there, the probability of 2 plus the probability of 3, that's what the P2 and the P3 means. The probability of 2 and the probability of 3 is going to be 0.1 times plus the 3.12. Sir, where did I get the 0.12 from again? Tell me.
So that's the value of A.
Very good. So I'm going to end up with a 0.46. I'm ending up with a 0.46. Now, the expectation of x, is going to be 1 times the probability of 1 plus 2 times the probability of 2 plus 3 times the probability of 3 plus 4 times the probability of 4. All right? And we know the probability of 1 occurring is going to be 3. The probability of 2 occurring is 0.1. The probability of 3 occurring is 0.36. And the probability of 4 occurring is 0.24. So it's going to be the 4.24, 4 times 0.24, 3 times 0.36, 2 times 0.1, and 1 times 0.3. And then when I add up all of those now, I'm gonna subtract it from my 2.54. Now remember the formula says the var x. No, I'm gonna get 2.54. That's part 3. Part 4 now. To evaluate the variance of x, the formulation is going to be the expectation of x squared minus the expectation of x all squares. The expectation of x squares minus the expectation of x all squares. Now, if the expectation of x is to multiply x by the probability of x occurring, it means that the expectation of x squared is going to be x squared times the probability of x occurring. So it is slightly different from the calculation above, but it bears some significance and some similarities. So instead, the first term is fine. I'm still getting 0.3 because 1 is a multiplicative identity. But the second case, up top in part 3, I have 2 times 0.1. But in the bottom part now, I have 4 times 0.1. Up top, let me see if I can spotlight. that line, no, sorry, that line, the expectation of X, look at it. It's going to be 1 times the probability of 1 occurring, which is 0.3. Then it's going to be 2 times the probability of 1. 3 times, sorry, not probability of 1, probability of 2. 3 times the probability of 3 occurring, and 4 times the probability of 4 occurring. And I'm saying to you, if you look at the variance of X, when you're working out the expectation of X squared, that value, it is the same thing as up here, except that the 2 is squaring, the 3 is squaring, the 4 is squaring. So instead of having 4 times 0.24, I'm going to have 16 times 0.24. See there? 16 times 0.24. Instead of having 3 times 0.36, I'm going to have 9 times 0.36. See there? 9 times 0.36. Instead of having 2 times 0.1, I'm going to have 4 times 0.1. 4 times 0.1. And the same thing, because 1 is a multiplicative identity. 1 times 0.3 is the same thing as 1 times 0.3, which is 0.3. Any questions? Hello, somebody? Any questions?
So we get a 0.1.
Where I get the 0.1?
Yes, sir.
You see it now?
Yes, sir.
Any other question?
Sir, a new topic is, sir. Reach late.
Good afternoon, sir.
Good afternoon. Good afternoon.
No, it's a new thing. We're looking at probability distribution.
All right, sir.
No, no problem, Papa. Talk to me. Háblame, 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 háblame. Talk to me.
Sir, can I explain them something about I talk? Like the var X and the EX coming on all them there.
All right. I soon do it. Do I have a taker to explain the expectation of X and var X? I just finished explaining it a while ago. So I'm giving somebody in the class an opportunity to do the explanation for me. Or you just wait until I do the other question. Any taker? All right, if not, you'd have to wait until I do the other question. The solution to the other question. I'm gonna ask you all now to, hey, to work on that one for me. The sum of the probability is always equal to?
1.
1.
Mm-hmm. So with that said, go ahead for me and calculate the value of B. You see the man giving 2 marks for that? Go ahead and calculate the value of B for me, please, quickly. Yes, I am.
So finish with I.
Finish with I. What is offer I?
B equals 0.14.
Is there 0.14? Is anybody agreeing with her?
So I got 0.14 as well.
Nice job. Very nice. All right. Let us find the expectation of X now. Remember, the expectation of X is going to be the the X value times the probability. So it's 0 times 0.12 plus 1 times 0.1 plus so forth and so on. As I said before, this is another way of calculating the variance and standard deviation. And I didn't show you the standard deviation just now. I think what we did was var X. For the first one, I'll show you the standard deviation now for this one. So just go ahead and calculate the variance. Now remember, the variance is going to be, var X is going to be the expectation of X squared minus the expectation of X all squares.
Sir, I found E of X.
Okay, and what you got?
2.22.
Anybody agrees with 2.22?
Yes, sir.
Okay, nice job. Good job. All right, the rest of you continue working, please. All right, go ahead and calculate var x one, please. I'll show you the standard deviation afterwards. Go ahead and calculate var x one, please. The expectation of x squared minus the expectation of x, all squares. Var x, the expectation of x squared minus the expectation of x, all squares. Let me know when you finish the variance of x.
That would be 0.59.
0.59. Does anyone agrees with her?
And you get 2.6.
You get what, Matthew?
2.6.
2.6. Anybody agrees with Matthew? All right, we soon double check that one. I don't want to post the answers yet. I soon double check that one for you. I want you now to look at this one for me now. Here, this one. I want you to determine the probability of x greater than or equals to 1, but less than or equals to 3. Find the probability of x greater than or equals to 1, but less than or equals to 3. Do that one for me quickly.
Just Alfredo.
Huh?
Sir, I got 7.5404 for the variance.
They don't
Okay.
say number 4 answer me tell if number 3. Come with things here so much get 3 and 4 or something like
Oh,
that. I'm
okay.
never there ear will or something.
All right. So say down the 3 yet? That's what they say?
No, but say I'm the 4. The answer
What you
of
get for
4 is 0.59.
anybody agrees with that? 0.59?
So I haven't done it yet.
Okay, all right. All right. So you move on to number 3 and let them do number 4 since you do number 4 already. Anybody finish? Nobody don't finish yet? Why am I asking the question and nobody answering me?
I'll say when I finish.
Yeah, I said something now. All right, 2 more minutes. All right, so I'm projecting Just confirm again with me, please. The probability of B, the value of B is 0.14, true or false?
True.
All right. And the expectation value is 2.22. I remember that value.
Yes, sir.
And var X is 2.6316.
Yes, sir.
Good job. And the standard deviation now is just going to be the square root of 2.6316. So you calculate the variance, and the standard deviation is just by taking
Sir,
the
can
square
you go
root
back
of.
up at the top, please, with the B?
Can I move on from B now?
Yes, sir.
Are you following, Cassie?
No, I am.
You're saying that you're not following, that's what you're saying?
Sir, may I follow you now?
Oh, okay. All right, so that's the value of B. And the expectation, remember, it's going to be the probability times the outcome plus the probability times the outcome. So it's going to be 1 times, or whatever it is, 0, in this case, 0 times 0.2, 1 times 0.1, 2 times 0.35, 3 times the value of B, 4 times 0.05, and 5 times 0.16. All right? To calculate the variance, we calculate the variance first in all the time. When we're calculating variance in standard deviation, we calculate the variance first, and in order to get the standard deviation, we find the square root. Find the square root of the variance to give us the standard deviation. Every single time. Every single time. And then I'm going to find the square root of 2.6316, and I'm going to end up with 1.622. And that is going to be my standard deviation for the data. Everybody got that?
Yes, sir.
Yes.
And then now, what is the probability? I want to make sure that you're following. So tell me, what is the probability of X being greater than or equals to 1, but less than or equals to 3?
Yeah, I got add up 1 to 3.
Yeah. And tell me what you get.
So I said less than or equal to 3.
Yes, yes, please. Tell me the answer, please.
0.59.
0.59. Everybody agrees with that 0.59?
Yes, sir.
Very good. 0.59 is correct. Johnny, are you seeing that now?
So I'm gonna get number 4.
So it says the probability of X greater than or equals to 1, but less than or equals to 3. It's greater than 1, but it can also be equals to 1. So when you have your inequality like that, greater than or equals to 1, but less than or equals to 3, it's an inclusive inequality. Inclusive. That means it's going to be it's going to include your extreme values, not just the middle value. So if they had said to you, what's the probability of X greater than 1 but less than 3, it's only 2 alone you could have used. So the answer would be 0.35. But because it says X greater than or equals to 1, but less than or equals to 3, you have to use a 0.1. You have to use the values 1, 2, and 3 because it's included. How you know it's included, sir? The equality sign to the inequality says that it's included. The equality sign to the inequality says that those values are, the extreme values are included. So it's going to be, I'm adding up the probabilities of the numbers. So it's going to be 1.1 plus 0.35 plus the value of B, which is 0.14. You see that now?
Yes.
All right. What's the comfort level so far?
So on a scale of 1 to 10?
Yeah.
6.
Sure, you can go down to the standard deviation.
Sir, can go
testing.
back at 3, please?
From a scale of 1 to 10, Tanil, how far are you?
6.
Okay. Anybody at a 9? On a scale of 1 to 10, how you feel about this so far? Anybody at a 9 or an 8?
No, sir.
Not sure. Anybody at a 1?
Yes, sir.
Let me talk quick about it, yes. I must say the grade 1 you talk about.
So sir, you just never mind, me see.
Talk to me. Those of you who are looking at it, are you okay now? Guys, where are we now? Can I move?
Yes, sir.
Yes, sir.
You know, so when you not ask me to go back and again go back, because when I go back and not finish with what you do, they don't say, sir, we
Wait,
finish,
sir,
you know.
wait, sir, wait.
Sure. Cassie, are you finished?
Yes, sir.
Let me say a while ago. When I tell you when you finish, you must tell me say finish.
Sabi na siya.
See, I have a pass with a question there. Start for me, please. I'm stepping away for 2 seconds. A past paper question. Start for me, please. Where's this thing? Finish?
Nope.
That was a no?
Yes, sir.
All right, take your time. Hurry up. Take your time, but hurry. Boy. Is the fraction equivalent taking so long?
Yes, sir.
Okay.
Sir, should the answer be a fraction since it was given that way? Or
If you want, you can put it in fractional form. If not, you can put it in
okay.
decimal form. Hmm. Or stay now.
Anything.
What is the expected value? In order to calculate the expected
So
value, what
that's
do you need to do?
EX.
Yeah. In order to calculate the expected value, what you need to do first?
You have to add up all of P of X equated to 1 and solve for K.
Very good. And what's the value of K?
30/61 or 0.49.
Everybody agrees with that for the value of K?
You can repeat that, please.
30/61 or 0.49.
Agree? Disagree? Johnny, do you agree?
Oh, sir. We don't know, because we never know if we do it, sir.
Very good, Tani and Shanti. Hey, boy, Johnny. Is it for the rest? Is it for the 2 more classes I'm gonna have with Uno? Make sure you're there before class start. Here, boy. Don't make it
Yeah,
bother this one.
you know.
Say it again.
No, but I say, continue.
Okay. All right. And yeah, you see, when you miss class, you miss instruction. Okay, you know, so Mr. Shan is one of them teachers that will come to class one time, and you know, when we're coming on late, we just start. All right, let's go. Look at it, Papa. So the sum of the probabilities equal 1. Every sum of probability that you add up, it's supposed to be equal to the sample space, which is 1. I am going to ask you again, please, students. I did ask before that you go through the unit in particular on statistics on Microsoft. I particularly ask you to do that. And I'm going to ask you again in preparation for your exams, please to go through the unit on statistics. There are 1 or 2 areas, or maybe 3 or 4 areas more that I need to go through with the statistics. And like tonight, I had a different plan of action. I mean, I kind of have the sniffles because the truth of the matter is I've been hardly sleeping, just like you guys. I'm up doing a whole host of things. SBAs, preparing classes, mid-semesters, etc., etc. My body is literally tired, and it's saying to me that, boy, you need to get some rest. So I'm going to ask you, I'm doing the best I can. I'm doing the honest best I can. Now, like tonight, I wanted to do something else. It looks like it's not going to happen because I am not going to go beyond 8:30 tonight. I really need to go and lie down and sleep in preparation for our 8 o'clock class tomorrow, because I'm inviting you to the class again. And that goes up until 12. So, you know, it's rough. It's been a rough period. This season has been very rough. But anyhow, we'll talk more about that afterwards. So what I'm saying to you, Johnny, and others who are not understanding, the sum of the probabilities will always be equal to 1. Now, if I gave you, as Tani says, k/2 plus k/3 plus k plus k/5, we're going to equate all of that to be equals to 1. Why, sir? Because the sum of probabilities must be equals to 1. The sum of probabilities must be equal to 1. Numero uno. The sum of all probabilities must be equals to 1. All right, let's go. So what I'm going to do is to say k/2 plus k/3 plus k plus k/5 is supposed to be equals to 1. Right? So we have to first find the value of k now in order to find the expected value. We can't just go again and just find the expected value without finding the value of k. All right. So look at what is happening now. So I am going to be multiplying throughout that equation by 30. So why 30, the LCM? Why, sir? So that I can get rid of the LCM, the denominators. So that I can get rid of the denominators. So I'm multiplying through by the LCM. So when I do that, I'm going to get k over 2 times 30, k over 3 times 30, plus k times 30, plus k over 5 times 30 is equal to 1 times 30. So why are you using 30 again? Because I'm multiplying through the equation by the LCM, the lowest common multiple. So every time, yes. Every time you get a question such as this, and you have an equation with multiple denominators, whether or not if it's multiple. If you had one denominator in it, in order to get rid of the denominator, just multiply throughout the equation by the LCM. All right, so now I'll end up with the 2 into 30 goes 15 times, so 15 times k is 15k. 3 into 30 goes 10 times, and 10 times k is 10k. 30 times k is 30k. 5 into 30 goes 6 times, and 6 times k is 6k. So 15k plus 10k is 25k, plus 30k is 55k, plus 6k is 61k. So I'm going to have 61k equals, why do I have that line 2 times? All right, so I need to delete one of those lines. So you have 61k equals 30, and k is going to be equal to 30 over 61, which is 0.49. That's the value of k. We don't finish the question yet, because the question asks us to calculate the expected value. So now I know what the value of k is. K is 0.49. Hello, it's 0.49 divided by 2, 0.49 divided by 3, 0.49, and 0.49 divided by 5. Do that and tell me if you got the 0.25, 0.14, 0.49, and 0.1 respectively for me.
Sure, can I repeat, sir?
Now I'm saying the 0.49 that we got for the value of k, we now have to say 0.49 divided by 2, 0.49 divided by 3, in order to find out what the probabilities are. So we have to substitute the values of k now. 0.49 and 0.49 divided by 5.
Sir, I left them in decimal, fractional form.
That's fine. What you got?
For 1, I got 15 over 61. For 2, I got 40 over 61. 3, I got 4 and 26 over 61. And for 4, I got 135 over 61.
135 over 61? No, you can't. Because the probability can be greater than 1. Remember I told you that?
Okay, sir.
Leave it as a decimal. Put it in decimal form for me. Put the value, put 0.49 divided by 2, and then write it in decimal form. Remember, guys, the sum of the probabilities cannot be greater than 1.
Yes, sir, me get them.
Nice job. Out of all of those, okay, 0.25 plus 0.16 is going to be 3 and 1, 4.41. 0.41 plus 0.1 is 0.51. 0.51 plus 0.49 is 1. So it works out. Just remember, the sum of the probabilities can greater than 1. Are you with me?
Yes.
Tony, you didn't get it yet, honey?
Yes, sir, I got the first one. I'm going to do the rest of them now.
All right, no. So look at the expectation. So remember the expected value. The expected value is going to be 1 times 0.25 plus, 2 times 0.16 plus, 3 times 0.49 plus, 4 times 0.1. Check that to see if you get 2.44, please. JVR, you are silent tonight with me, honey bunches. I don't like that, JV boo.
Same with the somebody there earlier and internet go away and I drop asleep. So I come back after 6, like 6:40. So I try to catch up.
We now say nothing because today I was supposed to be doing some work and I hear the voice of my pillow saying, come here. And I gave into it and I went and I lied down, little tubs, and was
Sir,
vexed when the
I got 0.65 for 2.
0.65, no, and check again. 0.49.
Oh, never mind.
divided by
That's for the var X thing.
So sir, when you multiply the 61 times the 0.49, you must get 30, right?
69 times what? 0.49? Yeah. 61 times 0.49 is supposed to give it 30, yeah.
So you get the 0.49 now. You divide the 61 by the 30?
No, 30 divided by 61.
Oh, that will
So you know what I had was right. What I was telling you was for the other question. I didn't set up a table like this for the. I just went straight ahead and calculated them.
Okay. Okay. So all of you now got the 2.44?
Yes,
I want
sir.
to make sure that my answer is right now because it was done in a rush. So I want to make sure that my calculations rather are correct. So 2.44 is correct. All right. So that's the expected value. What the question asks us to do, the expected value. So remember now, before you calculate the expected value, you had to calculate the value of K. Before you calculate the expected value, you had to calculate the value of K. There is no way you could have gone and calculated the expected value without first evaluating what K is. All right, it's very important. So with that said, we are now asked to calculate the variance and the standard deviation. So remember, the standard deviation is just going to be the square root of the variance. So the variance is going to be equal to the expected value of x squared minus the expected value of x all squared. The expected value of x squared minus the expected value of x all squared. So we have 1 times 0.25, 4 times 0.16, 9 times 0.49, and 16 times 0.1 minus 2.44 squares. And that's my variance. Did anybody get that? Remember the formula to calculate the variance. It's going to be the expected value squared minus the expected value all squared. So I'm going to square my x's and multiply by the probabilities.
So I got that in about. I got that for E of EX squared, not E, of before you minus the 5.9536.
What you got? You got the 21.16?
No,
No,
sir, the
I got the
6.9
6.9.
minus 5.95
Yeah,
something. So we get 21.16.
yes, sir. So that wrong.
Wrong bang.
So you add up
Leave me,
0.25 and
leave me alone.
0.64 and you get that big number.
I know when you see when
Tanil, you are a harsh teacher. Did you hear what you asked me a while ago? Sir, you can add a 0.25, 0.4 and get a 21.16, sir. Oh my goodness, Tanil.
Sir,
Take
but
time with
look how
me.
much zero there in the equation, sir, and you get
Take time with me. Hey, Johnny, you know, you're Tanil rough up your father. Eh? Oh my goodness, I don't know how. What did you say a while ago?
Leave me out of it and I'm your sheriff.
It's all right. It's all right, man. But you're right, though. How on earth I'm adding 0.25, 0.64, and end up with such a big number? My father gone. That's why I tell you, that's why I want you to do the calculations with me, because you don't know how we get that. I tell you, say, I need to go on a vacation and cool off my little headspace at 0.25 plus 0.64 plus 4.41 plus 1.6. And it's all due to JB, I come talk about wrong bang. It's all right. Yes. So yeah, so it's 6 point. And you said Ashanti then.
No, sir, it wasn't me.
So 6.9 minus 5.9536 all squares. Rockstone. Oh no, it's 2.44 squares. Give me 0.5936. See, something wrong with me tonight, because I'm getting a negative number, and I know say something wrong if I get a negative number, because I can't find the square root of a negative number. So there's no way I could find the standard deviation if that were so. All right. So my formula for var x then is going to be, sorry, my answer for var x is going to be 0.9464. Everybody get that? It's only up on TikTok.
yes.
The on TikTok in the I class. Make sure you get the 0.9464, Everybody agree with me? 0.964? 0.9464?
Yes, sir.
yes, sir.
Nice. And then now, all this gonna the variance is 0.972.
Yes, sir.
All right. Leave my variance alone here. I mean, my standard deviation, sorry. My standard deviation is going to be wrong because I don't know what was happening to teacher. Jeez, I'm going to come out to the exam and think me get 100%, I'm going to come out to the exam and think me get 100%. All right, so my standard deviation is wrong. My standard deviation is supposed to be 0.972 or 0.973.
So you don't lose 6 marks.
Oh, Jesus, talk truth. Oh, my goodness. No, sir. Anyway, it just shows how real a teacher can be. Teachers too can make mistakes. So, and I love when I make mistakes, because guess what? I am the first to laugh at my own mistakes. I don't even give nobody no chance to laugh off it. You see how me drop a road? Me first a laugh, Me first a laugh. Because nobody not gonna laugh after me. Me first a laugh. Me first. Yeah, man. All right. Let me ask the question again now. What's your comfort zone from a scale of 1 to 10? How you feel about the topic now?
8.
Okay. Johnny, how you feel about it?
Feel, it's all right, it's manageable.
And let me ask you
So
between
what, so what you say was the answer, sir?
0.973.
No, for the formula var at the top.
Oh, var x is 0.9464. var x, the variance of x, that's what it means. Var x, the variance of x is 0.964. All right, no case?
Yes, sir.
Natty D, hey, Natty, come off of the phone. Come off of the phone, Natty.
Sir.
Yes, talk to me. You did that on the phone a while ago. Talk truth.
Sir, my internet pick up good some can get pick up on TikTok, so no. Sir, I understand.
Let me tell you what I love about you. You're honest. And trust me, I keep saying, just tell me the truth the first time around. Let me blare up. Then you tell me a lie. And then I figure out later on, say a lie, you tell me. No, man, trust me. Tell me the truth the first time. And I like the fact that you tell me the truth. Yeah, but praise the Lord, so the internet gone say not on TikTok so that you can focus on teacher. But hold on.
Yes, sir.
Sir, and another thing, sir. You're
Yes,
minus 21 from the 5, sir.
Tani, leave me alone, no? Tani, leave me alone. Tani. Mrs. Henningham. Mrs. Henningham. Mrs. Henningham.
I'm right here, sir.
Can you tell Tani, can you take Tani to the principal's office, please? And tell the principal that Tani is being mean to me.
The principal might fire you.
Not true. The principal might say, but Mr. Shand, this is basic mathematics. How can you subtract 5.96 and get 6.9? Oh no, we need another teacher. I don't know. I look quite tight next to. I don't know what was wrong with me. Oh Jesus, forgive me, hon. Wait, all right.
And it follows through, sir. It goes straight to B.
Please, Mrs. Henningham, you're Tani related. All right, never mind. Trust me. It's good when we can laugh at our errors. Yeah, forgive me. All right. So part C3 says the probability. There's a trick with this one. Johnny, watch teacher. It says the probability of x greater than 2, but less than or equals to 4. So x greater than 2 at 3, but it's equal to 4, sir. Says 3 and 4. So we get 0.59. Anybody get that? Háblame.
Sir, I'm going to check.
Jeez, I'm telling you, that's a rubby thing say, man.
Sir, how you know how much P if you use?
Thank you for asking that question. Let me see if I can spotlight this thing. Oh dear. Oh, it's gone up here, so. Watch this case. Green, you're with me?
Yes, sir.
All right. So that inequality is read, x is greater than 2, but less than or equals to 4. X is greater than 2. Give me a value greater than 2, Kes.
3.
Very good. Give me a value that is less than 3 or equals to, less than 4 or equals 4.
3 or 4.
3 and 4. All right. So it says x is greater than 2. That means I can't use 2 because x is greater than 2. So I have to use 3, but X is less than or equals to 4. But because of that equal sign, which is an inclusive sign, I have to use the probabilities of 3 and the probability of 4. So that's how I get, oh, I can't do this thing. I can't navigate my screen with the spotlight on. Crazy stuff. So that's why I'm using the probability of 3 and the probability of 4, because it did say I'm to find the probability of it occurring when X is greater than 2, but less than or equals to 4. So I have 2 probabilities right there, 3 and 4. And the probability of 3 is 0.49, and the probability of 4 is 0.1. So when I add 0.49 to 0.1, I'm going to get 0.59. I'm not going to get 0.5 because there's a placeholder right there. That is 0.10. I connect the decimal places and do my stuff, I'm going to get 0.59. That much I know I'm correct on. Are you with me now? All agreed? Comfortable?
Yes,
Yes,
sir.
sir.
Blow. So sorry to play rough.
Continuous goal, sir.
No, if we continue scroll, I'm going to get the solutions. May I give you 10 minutes to do this, you know? Start for me, please. I can't even check my answer because you ain't see the answers. I mean, I want any laugh after me again. All right, one word. 10 minutes. No make no shoulder fling in my class, please. No fling and no shoulder in the class. You know what? I'm gonna try it. I'm gonna try it and see if it works. What time is it, Lord? Ouch. What's your 7:30? Not much time. Hold on there. I am right here now, guys. When you're finished, just let me know.
Finished.
Good. Anybody else finish with a nail?
Finish,
Yes,
sir.
sir.
Yes,
Very,
sir.
very nice. So if you never say it, you don't want to tell me. All right.
No.
No? Okay. I mean, knock you silly. All right. Let's go. Let's go, my side. Let's go. Let's go, my side. Let's go. Let's go.
Value
Let's
of D, 0.1.
go again. Eh?
D 0.1.
Same.
B 0.1.
D
Yes,
as
sir.
in dog.
Yes.
E as in dog, 0.1. Got that. Very nice. Everybody agrees with 0.1 as D.
Yes, sir.
Yes, sir.
Nice job. Casey, I'm not hearing you answering me.
Yes, sir. I'm gonna do it early, sir. I'm gonna get it, man.
Good job. The expectation of X greater than or equals to 2, but less than or equals to 4.
0.75.
Five.
Same.
Yes, sir.
0.75. Check. We step right. We say grade 1. Everybody agrees with 0.75?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
The probability
Wait,
of X
sir.
greater. Good. The probability of X greater than 2.
0.55.
Yeah, got that.
Yes, sir.
Very nice, Johnny. Very nice, the rest of you. Very nice. Love the sound of it. Woohoo! And then now, the probability of X greater than 2, but less than 5.
0.45.
What?
0.5.
0.5.
0.5, sir.
0.5.
Oh, I put in the 5 value for 4.
Is this karma?
Sir, calm down.
I love it. I love it. I love it.
Sir, I still not understand how you know when to use the P, them and how much P to use.
Can somebody explain to Casey for me, please?
All right. So that one say X value is greater than 2. So because 3, 4, and 5 are greater than 2, you're going to look for the P values. So yeah, the P values under 3, 4, and 5 and add them to get the answer. I get what I'm saying?
We say 2 greater than 2 less than X. If it's X less than 2, yeah, say?
No, for
X is
number
greater than 2.
3, it says X greater than 2. So you're going to look for the values greater than 2. So it's 3, 4, and 5. So you're going to look for the P values on the 3, 4, and 5 and add them to get your answer. To get the
But remember,
probability of.
but remember, no, do you know that P is that X is less than 5. So there's going to use 2 and 3. I mean 3 and 4.
Sister was talking number 3, not number 4.
Oh, my bad. Yeah. Sorry. Casey, you get it?
Yeah.
No, you don't get it. Tell me you get. All right, you don't get it. Listen to what I'm saying. Listen to what I'm saying. So the question in part 2 says, the question in part 2 says, let me see if I can. The question in part 2 says, right there, so, says, the probability of X greater than or equals to 2, but less than or equals to 4. The equal sign there to the inequality says that there's going to be an inclusion of those extreme values. What are the extreme values, sir? The 2 and the 4. So I'm including the extreme values because there's an equal sign to the inequality at the extreme values. So the inequality is red. X is greater than or equals to 2, but less than or equals to 4. X is greater than or equals to 2, but less than or equals to 4. So the mere fact that it is equals to 2 also, but it's greater than 2, that means it includes 3. And it says it's less than 4, but it's also equals to 4. So it's going to be 2, 3, and 4. Get that?
Yes, sir.
All right. Look at the contrast though for number 4. Number 4 says X is greater than 2, but less than 5. There's no equality. That means the extreme values are not included. The extreme values are not included. So how you know that? Because there is no equality to it. It is just X greater than 2 and X less than 5. There's no equal sign to it. Okay, sir. So what you're saying then, sir, is the only time the extreme values are included is when it is that you have an equal sign to it. Yes. Look back at number 2. Look back at part 2. Part 2 says X, I always read inside out. I don't want nobody to come read and say X is less than or equal to 2 is less than or equal to X. That will make it. You're reading inside out. You're reading from the X to the left and from the X to the right. I showed you this. I showed you this long time. You start with the variable X and you move to the left. Go back and start the variable X and then move to the right. All right. And then if you look at the contrast of it, you'll see that X is greater than, but it's also equal to 2. And X is less than, but it's also equal to 4. So those values are going to be 2, 3, and 4. The other one, P is greater than 2. It never said greater than or equals to 2. It's a P is greater than 2. So we're only interested in 3, 4, and 5. That's why I have P of 3, P of 4, and P of 5. And then the last part of that thing says the probability of X being greater than 2, but less than 5. It does not include the extreme values. So we are only interested in the values that fall between 2 and 5. That is 3, 4. Can we see that? Casey, talk to me now.
Yes, sir.
All right. And then when we evaluate P of 3, we're going to get 0.4 and P of 4. Probability of P at 4 is going to be 0.1. And 0.1 plus 0.4 is going to be equal to 0.5. So that probability works out to be 0.5. And the expected value now, the expected value is when I multiply 1 by 0.2, 2 by 0.25, 3 by 0.4, 4 by 0.1, and 5 by 0.05. See there? And I get 2.55. All agreed?
Yes, sir.
Yes, sir.
Nice job. Johnny, how you stay?
That me get to say.
Nice. Matthew, how you stay? Matthew don't stay at all.
Them good.
Is okay, good. Is Tyreek in class? Sir P? No? Maisha, where you stay?
Sir, I got it.
Nice job. Is Petrine here? Petrine? Job. All right, let's go. So the variance of X now, you remember, it's going to be the expected value squared minus the expected value all squared. So it is calculated similar to the expected value, except that we're going to square the X values. So it's going to be 1 squared times 0.2, 2 squares times 0.25, 3 squares times 0.4, 4 squares, 4 squares times 0.1, 5 squares times 0.05. Work that and tell me if you get, oh Lord, 1, 2, 3, 4, 5, 5, 6.
Yes, sir, right.
It's right? Okay, thank you. Praise the Lord. Oh, I didn't say that one. Okay. 3141516 7.2, 7.45, 7.65. Yeah. Cassie, you get the 7.65. You get the 1.1475.
Yes, sir.
Good job. Johnny, you got it, Pops?
No,
Matthew, how you
sir.
see? What, where you got it wrong?
I think the E times X squared, but
All
we
right,
get
Corp and
6,
check it for me. We get 6 what?
6.1475 for the part there.
Check it quick time for me, please. Quick time. Check it. Double check it. And then remember now, I'm moving on, but double check yours, please. Remember now, the standard deviation is just the square root of the variance. Standard deviation is just the square root of the variance.
Sir, but decimal place must stop, sir, for the standard deviation.
To be honest with you, as long as you give me about 2, at least 2. At least 2. If you notice so far with my calculations, I'm always consistent with about either 2 or 4.
Sir, we can see about the table. All right, sir.
Are you okay, guys? I'm waiting on you to tell me that you're fine.
Yes, sir. Good.
Okay.
Yes, get the correct answer.
Nice. Very good. All right, so I'm going to stop sharing here. This is the end of my probability distribution. I don't have any other questions to give you on it.
So we're done.
Huh?
Done for today.
No, Matthew. I know you're tired, Matthew, but trust me. I'm as tired as you are, Papa, if not a little more tired than you. And I don't know if you can hear it, but I'm having the sniffles, but I'll soon be finished. I just want to introduce, oh Lord, help me. Where is it? Where is it? Soon finish, Matthew. Never mind, Papa. Well, actually, I can just give you a all right. So very quickly, I won't spend more than about 15 minutes on this, maximum 20 minutes.
Sir,
Yeah,
sir, I did
go ahead.
mark somewhere someone was sending Erica staff last week, Saturday.
No, when we reach a class tomorrow, we'll talk about that one day.
Okay, sir.
Cool. The measures of central tendency. When we speak about the measures of central tendency, we're talking about the mean, the mode, and the median. We looked at this already, but it's just that I need to fine tune some stuff to it. So once you hear the question talks about the measures of central tendency, just make sure that you know you're talking about the mean, the mode, and the median. The mean, the mode, and the median. All right. And more from the raw data, you know what to do. You add up all of the numbers, divide by the number of numbers. All right. You add up all of the numbers and divide by the number of numbers. The median or the middle quartile, which is your Q2, you know that, of the set of data is a middle observation when the set of data is arranged in numerical order, ascending or descending. So you can put it in increasing or decreasing order, you should get the same thing. It divides the set of data numerically ordered into two equal parts, right? It divides it into two equal parts. The median or the second quartile or Q2, when numerically ordered, the data divides into 100 equal parts, then each division is called a percentile. All right. Now, let me just go back to something that I'm just making some connections here that we spoke about. I know, Miss, I think between Miss and Tanil, if I'm not mistaken, we're having a conversation about the Q2 or some box and biscuit plot, something of the sort. Now, what it was saying, based on some things that we see online, when they have an even number of numbers, all right, let me start with the odd one. When they have an odd number of numbers, they were including that odd number, the middle number Q2, into the calculation of Q1, which is incorrect. That's not what I'm teaching you. That's not what I'm teaching you. The Q2 separates the data in equal parts. So I'm looking at all the numbers less than Q2 and all the numbers greater than Q2. I should have an equal number of numbers to the left and the right of Q2. Then I'm going to find the middle of that number. So if you have an even number of numbers, it means that your Q2 is going to fall between as a middle number of those two outer numbers. So therefore, that number is going to be included in your Q1 and Q3 code. All right, please be careful of that. It's just like, yes, Kes?
Sir, I'm not seeing anything on the screen.
No, am I not showing anything?
I'm seeing it.
Sir, I'm seeing it.
Oh. I am sharing, but what I'm talking about now is not what I'm sharing, it's just a point of information that I'm making. So I want you to hear me out. I reviewed 3 books for Nelson Thorns, STP1, STP1, STP2, and STP3. And while I was reviewing the books, inside of one of the books, the man them said to me, say, 1 is a prime number. I have to write them, STP come out of England, you know. I have to write them and tell them, say, take it out of the book. I say, only take it out of the book because 1 is not a prime number. I said, please to make sure that before I send my corrected version of the book to you, you remove from the book that 1 is a prime number. Because we don't want nobody say then, oh, Mr. Shand did review the book here and it come out with such an error. And the response that I got from them, it was that it was an oversight. And it was sent to a reviewer before me, and the reviewer never said that mistake. So I had to sit down and read through the whole book. You talk about when you can't read maths book, and if I sit down and read through the whole book, some enough pages, just to make sure that the things are correct.
Also,
so
sir,
I say, go ahead, Miss.
I'm seeing those types of errors, especially when you look for online books. So you have to look for other sources to corroborate the information.
Absolutely. Wikipedia is something that is not trusted. So
but
yeah,
books, text, sometimes you'll find textbooks and you're seeing it and you see the errors as well.
Right. So we have to be very careful. So I mean, I had to write them. There's another thing that pops out at my from memory now that I had to write them about. You know that a chord touches 2 points on the circumference of a circle. So I said to them, include in your definition that the diameter is a chord. And the man them, bigger man them than me, you know. Cause them lecture now, a foreign university. Me I want to look at localites. And I said to them, no, the diameter is a chord. And one long piece of email back and forth. I know it was so surprising. Or not surprising, but interesting. When I was doing A-level, that's the book written by those same people I studied from. And even in that book, I found errors while I was studying. Even in that book, I found errors while I was studying. So I'm saying to myself, but look at me, know Jesus. And my teachers, they may talk to you and I make corrections too. So which is why when Tani says, sir, or if you make that mistake, I laugh because mistakes, yeah, mistake what they for make. And you have to learn from the mistakes them. That's why God is such a good God, because He don't kill you when we make mistakes. Hopefully we learn from them and don't make them again. When it becomes habitual, it's a problem. So I had to tell them and them say, the diameter is a special chord. Why is it special? It is special because it cuts the circle directly in half. But the other chord touches two points on the circumference of the circle. No, if the chord touches 2 points on the circumference of the circle, it must be it must be a chord. Here's the final example I'm going to give you. A square is a rectangle, you know. Do you agree with that?
Kind of.
Okay. Anybody else agree?
If you do a diagonal cut, you'll get two triangles, right angle triangles.
Okay. The square is a rectangle. The square is a rectangle. However, it is a special rectangle. Why special? Because the length is equal to its width. A square is a rectangle, but a rectangle is not a square. There is no way can a rectangle be a square, but a square is a rectangle. Why, sir? It's a special rectangle because the length is equal to its width. The length is equal to its width. So it's special, but a rectangle cannot be a square. And let me just explain to you why 1 is not a prime number. Because the definition of a prime number says it has exactly 2 factors, itself and 1. So 1 can't be a prime number because of two distinct factors it must have. And 1 are the same factor. So 1 is not a prime number. So the first prime number is 2, then 3, then 5, then 7. 9 is not 1. 9 is a composite number because a composite number is the opposite of a prime number. A prime number has exactly 2 factors. A composite number has more than 2 factors. So 2 is a composite number, 6 is a composite number, 8 is a composite number, 9 is a composite number, so it's 10. 11 is prime, 12 is composite, 13 is prime, 14 is composite, 15 is composite, 16 is composite, 17 is prime, 18 is composite, 19 is prime, 20 is composite, right? So so you have to have an appreciation of what it is that you're doing, or else you can go and miscommunicate, you know, something that is not, it's not correct. All right. So that is that. All right. So you know how to calculate the mean, mode, and median from the raw data. From the raw data, you know how to do that. The man them now, you know, raw data, you know, that's a 6 something. See there? From the raw data, you add up all of the x's, x1 plus x2 plus x3 plus all the way down to xn, and divide by n. N is a number of items that you have there, or the number of observations. So you know how to do that. I didn't show you, but you know how to do that. To calculate the mean, mode, and median from that data, all you do is just add them up in put them in sequence, correct sequence, and you do your stuff, right? You know how to do that. That I'm not concerned about. Really, I'm not concerned about that. To the point where I want to spend time to do that. This is what I want us to spend 1 more minute on. All right, group size, a range. The range is determined by subtracting the minimum value from the maximum value when ordered, when placed in increasing order or in or decreasing order. So it's a maximum minus a minimum value. And that gives you the range of the data. That gives you the range of the data. All right. Let us look at to calculate an approximate group size. We divide the range by how many groups you like. Suppose, for example, and this is what I want you to do. Suppose for 53, 56. Suppose, for example, they give you that data. They give you that data, 59, 60, 50, 65, 61, 62, 53, support, and so on. And they ask you to group the data. They ask you to group the data. To calculate an approximate group size, we're going to divide the range by how many groups you would like. You have to first arrange it in increasing or decreasing order. See, I did it there. 53 is the lowest. 70 is the highest. 53 the lowest. 70 being the highest. So what you're going to be doing is you're going to be rounding. Where am I? So to calculate the group, we're going to divide a range by how many groups you'd like. So if I want 5 groups, I'm going to have 70 minus 53 is how much? 17. 17 divided by 5 is going to be 5. 17 divided by 5 is how much? 5 point something. No, 3 point something. What is wrong with me? 17 divided by 5 is how much, class?
3.4.
3.4. So that means your group size is going to be 4 because you're rounding up. So it's going to be 4. All right. So let us look at this particular example here. So in this one here, for example, like 2 instead of 1.83. So if when you do the division, you get 1.83, you're not going to put 1, you're just going to round it up to 2. So if when you do the calculation, you got 4.26, all you do is round it up to 5. So in order to obtain 4 groups from our given set of data up here, so in green, 4 groups from our given set of data in green, it's going to be 17 minus 53, which is 70 minus 53, which is 17. 17 divided by 4 is going to give me 4.25. So my group size is going to be 5. My group size is going to be 5. All right, so that's where you get your group size. And then remember your frequency here is going to tell you the 51 to 55. I have 2 numbers that fall within 51 to 55. See it up there, so 53 and 55. Then the group between 60 and 56 and 60, I have 7 numbers that fall between them. 61 and 65, I have 8 numbers. 66 to 70, I have 4 numbers. And in total, I'm supposed to have 21 numbers. No. When me check up all of my raw data, make sure me have 21, or else something will be wrong. Just like what Sir did. Remember what me said? I followed through with the error in my calculation for part B of that question. So how the examiners would mark that? They would have penalized me for the first part. And clearly it's copy and paste, a copy and paste something and never finished the copy and paste process. So they would have penalized me in the first question, but in the second part of the question where It is still wrong, you know. But because I followed through with the incorrect answer from the previous question, I would have gotten full marks for the second part of the question. But they would have only penalized me for the error that I made in the first part of the question. So if the question carried 5 marks, I could get as many as 3 marks out of the 5, which for me is much better than getting 0 out of 5. Fair enough?
Yes, sir.
All right, let's go. All right. Yeah, that's what I wanted to say to you. I mean, I can't send you the document, but I just wanted to show you. All right, remember I was saying to you that when I was doing that question, I never had a formulation. No, I did up the stuff with the formulation here for you. So this is calculating the median from the group data. I've done this with you before, not going to spend the time to do it again. I've done this with you before. You have the formulation there now. And the definitions of those. L is a lower class boundary, and N is a number of values. B is a cumulative frequency, as I did say to you, and G is a frequency in the middle group. R is the width of the group. All right, so you can read through the document, and then now the document has additional questions that I would want you to do. I've gone through this already with you. So the group here 170. So when you're doing the calculation, you use 8, 9, and 11. See here. Why not using 8, 9, and 11? Right, yeah. 9, 6, 11. 9, 11, 6, yeah. Right, so you can go through the document and see how it is. Just to refresh your memory, how to calculate the median, the median from the grouped data. As I said before, I've done it with you before. I just prepared some additional questions and did a solution. So it is that you can have a look at it. So we're getting closer to finish off. So that's the end of that document. We're getting closer and closer now, guys, to complete the stuff. But fatigue has taken the best of me right about now. I know you two are supposed to be feeling it because you have papers to to prepare for and to write. I'm going to challenge you to be committed to the task of studying, practicing with friends, doing past paper questions, learning from those mistakes until we master what it is that we're doing. I'm very hopeful. I'm feeling and hoping to be. I'm feeling confident. I'm going to keep the level of confidence flying high because I know we are going to be successful. Those of you who are dragging your feet, literally dragging your feet, and you know yourselves, there is still time. There is still time in order to get through with what it is that you want to get through. Have a wonderful rest of the evening. Sleep tight until we meet again tomorrow, God's willing. Good night. Remember to say gentle Jesus.
Yeah,
Bye, sir.
No, no problem.
Bye, sir.
Bye-bye, honey.
Bye, sir.
Bye-bye, dears.